you can't just look for a key that doesn't exist. So this is a fresh brand new dictionary. We do a constructor there and we print out sub csev and boom, it blows up, and that's bad. But we can solve this by the in operator. The in operator we've used in the for loops, we've used it in lists, we've used it in strings. So that is a question. It's saying, is csev in ccc? Well, this is this empty one, and so it is no, it is not. csev is not in ccc. And so using this in operator, we can avoid the traceback. We can say, if it's not there, put it in. If it is there, add 1 to it. And that leads us to this bit of code. Okay, and that is the kind of code that we're going to build a histogram. This is going to histogram code. Okay, and so this is going to have name as our iterator, names. Sorry, I made them singular and plural. That's nice, but so name is going to be csev, chen, csev, gen. Now normally we'll be reading this from a file, but for now we'll keep it easy. We're going to go through this. And we're going to have counts as our dictionary. So that starts out empty, and we're going to do a simple if then else every time through the loop. If the name we're looking at is not in the dictionary already, is the key, then set it to be 1. If it's not, go get the old value, count subname, and then add 1 to it and stick it back in. So this line right here is new, adding a new thing, and this line right here is adding some things to existing things. And you do this long enough, you start with an empty one, and you do this long enough, at the very end, it will print out the histogram that you're looking for, the histogram you're looking for. And so you say, oh, we've seen csev twice, gen once, and chen twice. And so that's the idea. And so this can run 1,000,000 times if you want. Now, this notion of checking to see if a key exists and doing one thing if it doesn't exist and doing another thing if it does exist is such a common practice that the dictionary object has this method called get that collapses these 4 lines into 1 line. And so the idea is you're going to do one thing if it's in there and you're going to retrieve the current thing. Otherwise, you're going to pick a default value. In this case, we'll pick 1. I mean, pick 0. This is like the default, right? Meaning what is not there. And if you say counts, now counts is a dictionary, .get, that's like string.upper, that's a method. You give it a key and then a default. And if the key exists, you get back what's in the key. If the key doesn't exist, you get the default. Okay? So, and with no traceback, this works. So the best way to think about this is those 4 lines are equal to that 1 line, because X is either going to be whatever was in there before if it exists, or it's going to be 0. Now, the nice thing about 0 is the next thing we're going to do is we're going to add 1 to it, so that's going to get us to 1. So collapsing that loop that we saw before, we can make it just a 1-line loop, and this will become an idiom. This will become something that you will get used to and you will use over and over and over again, and after a while, right now you're looking at it, boy, that's a lot of syntax and semicolons and whatever. After a while, you just type this and not even think about it. It's an idiom. It's basically included in this idiom is how to both create new entries in dictionaries and update existing entries by adding 1 to them. So everything else in this is the same. Name is going to go through these 5 values, and we're going to say count subname equals counts.get name, comma 0 plus 1. And so if, for example, this already has a 1 in it, then this is going to be 1 plus 1 becomes 2. If it's not, it's going to be 0 plus 1 equals 2. And so this is the idea of if new, set it to 1, not 0, set it to 1. Because the first time you see something, the count should be 1, not 0. So that's why we make this default. Now the get can be used for anything. It just so happens that 0 is a common default because it's really common that we're using this to basically make a histogram, right? Little histogram of A, B, C, right? And so we need to make a D, but then the histogram has to start at 1. So that's basically the simplified counting with get. And you know, there's a lot of things that we're going to do inside of Python that do have to do with frequencies and how many times certain things happened, and this pattern is a really good pattern to absolutely know. So now what we're going to do is we're going to switch from just looping through strings, but instead loop through files. And it's going to take a little bit of work because we have to open the file, and we'll bring a lot of things together at this point. So here would be another task, and that is here's a bunch of text from the book, And you can just split this into words and count and find out what the most common word is and how many times it occurs. So go ahead and try to do this for a second. Feel free to pause. Actually, don't bother pausing. This is too hard. We should write a program for this. It's not easy. Humans don't like this. It makes you concentrate. And so here is a counting pattern where we're going to take a line, and then later we'll read this in a file. And so this is just an adaptation, improvement of the previous thing. So we're going to start with an empty dictionary. We're going to ask for a line of text and read it in. And then we're going to use split. So remember the list of words? Well, what we're going to get here is a list of words. We'll print it out, and we'll run this counting. This is the little loop. For every word in whatever this was, we're going to do this idiom of either adding a new entry or adding one to an existing entry, and then printing that out. So let's take a look at what we get there. So if we run this, we can give it some text, and I've got this will be all one line, and then it splits it into words, and you see that these words here are split, 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 split. I mean, that's strings and splits. Remember, strings and lists and split. And so now the counting is going to go through this list. The clown ran after the, and it's going to build a histogram. The clown, one clown, the up, these things are going to go up, right? That's this histogram. And then when it's all said and done, we end up with the histogram. And so counts is the dictionary that ends up with a histogram. And we can, by inspection, see, oh, the is the most common word. And there are 7 of those, right? So if we sort of take a look at this, we start out, we make a dictionary, we read in a line of text, the text goes in, and then we split that and we print the words out. So these are the words, right? Then we have a for loop that's going to loop through all those things and then produce a dictionary. And when we print the dictionary out, that's what we're going to get. And the is 7, okay? So that's one line of text. That's how you walk across the words in a line of text after you've split the line into separate words. So now we're going to look at ways that you can loop through dictionaries. We just produced a loop that can build a dictionary, but now we're going to look at a dictionary. And so we'll start with a very, very simple example, and then we'll work to a slightly more complex example. So here's a dictionary, just the constant. Chuck is 1, Fred's 42, and Jan's 100. And so we're going to use a definite loop with the for key and counts. Now it doesn't have to mean key, but key is a good name because these are keys and values. K, V, keys and values. I just mentally think of this as keys and values and keys and values. So this iteration variable is going to walk the keys. It's not going to walk the values. It's going to walk the keys. Chuck, Fred, Jan. Not necessarily in that particular order. As you see, it goes Jan, Chuck, Fred, because just because I typed it in this order, it's not like a list. It doesn't stay in that order. It might move around a little bit as we add data to it or as we set the data up. And so you can, in the loop, you can get the key, and so that's what prints out the Chuck, Jan, Chuck, Fred, but then you can also get the corresponding count for each one of these by just pulling it out of the array. Pulling it out of the dictionary, right? And so we can pull out the corresponding value, and so we print out Jan 100, Chuck 1, Fred 2, and that runs this loop 3 times. So if you just use the in and you give a dictionary here, remember all the different things we've been able to put there on the end of a for loop, and dictionary is another thing we can put on, and we get a list of keys. Now there's a couple of methods that allow us to get the keys, and so we have, we can say turn this into a list, and we get a list of the keys. So this is a dictionary, the same dictionary. We get a list of the keys. You can also get a list of the keys by using the keys method. So that's take this dictionary JJJ and give me all the keys, which gives me a list, which is kind of the same thing. And then we can ask for the values, and they give me just then the values extracted out of this dictionary. So that's nice. Now the one thing is that while I said you can't predict the order, if in 2 statements you ask for the keys and then the values, they at least come out in the same order, even though you can't necessarily predict the order that they come out. They come out in the same order. And then there is a third thing that we can do, and that is ask for the items. And we can say, give me the items. And that gives us a list. This is our first really kind of composite combined data structure where it is a list, a 3-item list, 0, 1, 2, and inside that there is what are called 2 tuples. Jan maps to 100, Chuck maps to 1, Fred maps to 42. Coming up next, we're going to have a whole chapter on that, and so just take a look at that for the moment, and we will come